In this video, I would like to introduce to you our redesigned 1.5 kilowatt microwave plasma torch system. The system consists of several parts. To my left, the power supply, in the middle, the torch itself, and to my right, the control system. The control system has been redesigned and it now combines the controller itself as well as mass flow controllers. The system also consists of several accessories and cable assemblies. So in this video, I'm going to show you how to make connections for the first time, as well as how to ignite plasma for the first time. At its heart, the system consists of a 1.5 kilowatt microwave plasma torch. This torch weighs less than 4 kilograms and it's made mostly of aluminum. The source of micro energy is mounted right on the top of it. The system also includes a sparker, which throws a spark when plasma needs to be ignited, and it also includes a quartz tube with 18 millimeter inside diameter. Please note that this is an electrodeless system, which means that it does not include any electrodes to ignite and run plasma. On this side of the table, we have a power supply. This is a special kind of power supply which produces high voltage to run the magnetron. On the input side, we connect this to the wall. This power supply runs on single phase 208 to 240 volts AC, and then it internally produces 4000 volts, which is then connected to this magnetron via high voltage cables. This power supply also connects to the controller box itself to communicate. To connect the two together, we use an RJ45 cable. But please note, this cable, although it is the same kind of a cable used for computers, the protocol itself is different. So please do not use Ethernet on either one of these. Simply connect them together for the proper communication. And finally, to my right, our redesigned control system. This control system is an all-aluminum body with a switch in front to start and stop plasma. It's also an indicator when the controller box is on, turned on. From the back side, we have a number of connections. To my right, here's an AC input, which accepts AC voltages from 120 to 240 volts, single phase. There's also a switch on top of it. This switch turns the unit on and off. Next to it is a USB port, which connects to your computer for communication. Next to it, HVPS port. This port connects to the power supply itself to talk to it. Here's a connector which connects to the torch itself via this cable assembly. And then here on this side, we have gas inputs and outputs. On the top, these three ports are for gas inlet, and these connectors on the bottom are for gas outlets. Right next to it, there's a connector to connect this interlock switch. The purpose of this interlock switch is to shut the plasma off quickly, simply by pressing the button, or to prevent plasma from starting in first place if the switch is engaged. To disengage the switch, simply turn, and the switch now disengages. You cannot ignite the plasma when the switch is on. You can only ignite plasma when the switch is off. Okay, so I'm now going to talk about how to make connections. First, let's take a look at the torch itself. There are a number of connections that need to be made on this torch. We'll start by connecting this high voltage cable to the sparker. On one side, it is already connected to the ground, and on this side, closer to the plastic piece, we have a red wire which carries high voltage close to 30,000 volts into the torch holder itself. Please keep your hands away from this cable and from this assembly while the system is igniting. Once the system ignites, it is then safe to touch the body and this section of the torch itself. At the back of it, there are a number of connectors. Here, here, and here. We have a short piece of cable with 3 wires. We'll connect one end of this cable. It does not matter which one, just one end of the cable to the board underneath. The purpose of this cable is to connect the thermal sensor to this interface board. From there, we'll take our multi-wire cable and connect it to the torch. This end with this long connector connects it to the controller, while on this side we have 3 connectors, or rather 4. The short one, shorter end of the cable, connects here at the very back of the torch. This longer white cable connects here. And then finally, these 2 quick disconnects connect to the spark gate itself. It does not matter which wire on these 2 you connect, left or right. The system will work equally well. From there, we're going to make a water connection between the magnetron and the torch. And this unit now, last thing that it requires are these gas tubes. We have 2 tubes. Single tube here connects to the top. This is our plasma gas tube. Simply screw it in. Has a fitting. You will need an 8mm wrench to make it tight by hand. And there's another tube here, which is similar but slightly different, which connects on the lower side of the torch holder. The difference between 2 is on the inlet side. Here we have a Y connection, and on this side we just have a fitting with an insert. So we're going to screw this in into the torch holder. And again, you will need an 8mm wrench to hand tighten this fitting. So we have now made all of the connections to the torch on that end. We are now going to make connections for the high voltage. We have 2 cable assemblies. One cable assembly consists of 2 cables connected together inside of this connector here. This connector here connects to the magnetron. And on this side we have special kind of connectors, both of which connect to the top of this power supply. So remember, we have 2 ports. They're both on the top, and the third one on the bottom is actually ground. So the ground will be connected to the ground of this assembly here, of the torch assembly. So this second cable is a single cable. It connects to the bottom. And it connects to the torch right here. So what we've done here, we've connected the torch to the controller box, or rather connected the cable, which will then be connected to the controller box. We connected high voltage cables to the power supply itself. We made gas connections here, and we've also made a connection for water cooling. So the last thing that remains to be connected to this system is the water line. The water comes in here and it comes out here. The purpose of the water for this system is simply to cool the magnetron off, as well as to cool off this interface here. So for instance, if this torch is connected to a reactor, which over time is going to get hot, this water cooling jacket here prevents the heat from transferring over from the hot reactor onto the torch body. So the water line, which supplies the system, basically cooling both the magnetron and the torch itself. Off the camera, I've just rearranged things a little and made the rest of the connections, and I'm now going to show you close-ups of these connections. As you can see from the back side, there are quite a few connections. So let's take a closer look. So, looking back at the back of the controller unit, we have the AC cable, which is connected to the wall outlet, 120 volts, followed by the USB port connected to my computer. Right next to it, we have the power supply control cable, which is connected over here. Next to it, we have the torch control cable, which I've described in the previous video clip, followed by gas tubes. This first gas tube to the left is the plasma gas, in this case air. One next to it is argon. Argon line is used only during ignition for about a few seconds. And below that, we have gas outlet tubes. So one in the middle is the plasma gas output, which connects over here. The Y connection here connects between aux1 and argon out, and on this end connects right here. And of course the interlock switch here, which needs to be disengaged, unlocked, for plasma to ignite. On this side, I have also connected the water lines. This is the water inlet, this is the water outlet to cool the magnetron. This system delivers about 5 liters per minute of water flow. The power supply has also been plugged into the wall outlet, and it's currently powered on. So let's switch on the unit. And finally, we are ready to ignite the plasma. So, to ignite the plasma, there are several things that need to be in place. First of all, gas lines need to be pressurized. There needs to be about 4 bars, or about 65 psi of pressure for both air, plasma gas, and argon. Second, water needs to go and flow through these lines to cool the magnetron off. And then finally, the exhaust system, which you can hear it making a lot of noise, needs to be running to capture and pull out all of the exhaust gases. To get the plasma going, all you have to do is just press this button in front of the box and then wait for about 15 seconds. And there it is. So this is our plasma. The plasma has ignited without the computer itself. The computer is currently powered down. Everything that needed to happen happened inside of this box, and the system itself is currently controlling the plasma, reading all the interlocks, reading all the sensors. Everything is in place, and it will continue to run for as long as all the gases are in line. We have gas pressures, and as long as the system is not overheating. To shut the plasma off, all you have to do is just press this button again. Let's do it again. 50 seconds is required for the magnetron to preheat before it will put out microwaves. Every time you start the system, 15 seconds of preheat is required. And there it is. This is our air plasma, 1.5 kilowatt level. If you wish to shut the plasma off using this switch, all you gotta do is press the switch. You will not be able to ignite the plasma if the switch remains pressed. So this is a safety interlock. To be able to ignite the plasma again, unlock it, and then press the switch again. And this brings us to the end of the video. As I've demonstrated, the system is quite simple to run and operate. Once you make all the connections, all you need to do to start plasma is press the switch up front in front of the box, and to shut it off, you just press that switch again. For more control, you need to have the software, our software, installed on your computer. Any one of the Windows computers running Windows 10 or Windows 11 will do just fine. And the software will allow you to change flow rates, to change power level, and to make some adjustments. If you like this video, please subscribe to our channel, and we'll see you in the next one.